This video is about the relationship between two planes. Given plane pi1, pi2 with the normal vector a1, b1, c1 and a2, b2, c2 separately. When two planes intersect into a line, r equals a plus lambda b. The direction vector of the intersection line is vector b, and vector b equals n1 cross n2. You have two ways to figure out intersection line. I will show you later on. If theta is the angle between normal vector n1 and n2, then the angle between the planes is also theta. Therefore, cosine theta equals n1 dot n2 over length of n1 times length of n2. If the two planes are parallel, which means the normal vector n1 is parallel to normal vector n2, which means n1 cross n2 equals 0, or n1 equals k dot n2. When these two planes are coincident, still n1 is parallel to n2, which means n1 cross n2 equals 0, or n1 equals k dot n2. And also the equations are multiple to each other. In other words, a1 over a2 equals b1 over b2 equals c1 over c2 equals d1 over d2 equals a constant number m. In other words, when this is true and this is true, the two planes are coincident. The plane pi1 contains the point A and the line L. Find the equation of pi1, giving your answer in the form r dot n equals d. We know this is a position vector, labeled as a b on the line L. The coordinate of b is 1, 2, -2. This is a direction vector, -3, -1, 4. On the plane, we have a point A and a B. So, vector C equals vector AB equals easy, ending minus starting 1, 2, -2 minus 0, 0, -2. Change minus into plus, change sign, equals 1, 2, 0. Then normal vector of the plane equals B cross C equals -3, -1, 4 cross 1, 2, 0 equals, cross out the first row, 2 by 2 determinant, -1 times 0 is 0 minus 4 times 2 is 8. Second row cross out, negative sign, parentheses. -3 times 0 is 0 minus 4 times 1 is 4. Cross out the last row. Negative 3 times 2, negative 6, minus. Negative 1 times 1 is plus 1, equals negative 8, positive 4, negative 5. So the equation of pi 1 r dot normal vector negative 8, 4, negative 5 equals, we do know D equals vector A dot normal vector n. Vector A is the position vector. Let's use A. A is easier, 0, 0, negative 2. Dot, negative 8, 4, negative 5 equals 10. So final answer R dot negative 8, 4, negative 5 equals 10. Let's go to B. Pi 2 has the equation 3x minus y plus z equals negative 13. Let theta be the acute angle between pi 1 and pi 2. Find the cosine theta. Let's get the normal vector of pi 1, negative 8, 4, negative 5. Normal vector of pi 2, 3, negative 1, 1. We do know the acute angle between pi 1 and pi 2 equals the acute angle between n1 and n2. Therefore, cosine theta equals n1 dot n2, length of n1 times the length of n2. Length of n1 equals square root. Negative 8 squared is 64, plus 4 squared is 16. 5 squared is 25, equals square root 105. And the length of n2 equals 3 squared is 9, negative 1 squared is 1, 1 squared is 1, equals the square root of 11, equals n1 dot n2, negative 8 times 3, plus 4 times negative 1, plus 1 times negative 5, over square root 105 times the square root of 11, equals negative 33 over 105 times the square root of 11. Since theta be the acute angle, we will put absolute value equals 33 over square root 1155. If this question is calculator based, we can figure out this theta. First of all, go to mode, change radian to degree. Alpha y equals 33 over square root 105 times 11. Enter. Then second cosine. Angle is 13.8 degree. Theta equals 13.8 degree. Let's go to C. Given that pi 1 and pi 2 meet in a line L1, find the vector equation of L1. We will change pi 1 into Cartesian form. Negative 8x plus 4y minus 5z equals 10. Then we try to solve this system of equation. 3x minus y plus z equals negative 13. Method 1. We will figure out the direction vector equals n1 cross n2. n1 is negative 8, 4, negative 5, cross 3, negative 1, 1. Simplify negative 1, negative 7, negative 4. Then we need to figure out the position vector on L1. We will solve this system of equation by getting rid of one variable. This is the first equation, second equation. Second equation times 4. 12x minus 4y plus 4z equals negative 52. Label this is the third equation. First equation, negative 8x plus 4y minus 5z equals 10. Let's add these two equations together so that we can cancel negative 4y and a positive 4y. 4x minus z equals negative 42. Let's make x equals 0. Then negative z equals negative 42. Z equals 42. Plug back to the second equation here. 3 times 0 minus y plus 42 equals negative 13. Negative y equals negative 13 minus 42, negative 55. Y equals 55. So the position vector of L1 is 0, 55, 42. The vector equation of L1 R equals 0, 55, 42 plus lambda negative 1, negative 7, negative 4. Method 2. Let's make x equals lambda. Then 4 lambda minus z equals negative 42. Solve for z. Negative z equals negative 4 lambda minus 42. So z equals 4 lambda plus 42. Then we substitute x, z into the equation 2 to figure out y. 3 lambda minus y plus 4 lambda plus 42 equals negative 13. Combine like terms, negative y plus 7 lambda plus 42 equals negative 13. Negative y equals negative 7 lambda minus 55. Y equals 7 lambda plus 55. In this way, we get the parametric form of L1. X equals lambda. Y equals 7 lambda plus 55. Z equals 4 lambda plus 42. X, Y, Z equals 0, 55, 42 plus lambda 1, 7, 4. So R equals 0, 55, 42 plus lambda 1, 7, 4.